Hello friends, welcome back to our channel Smart Techie, and today we shall be dealing with few of preliminary relationships. So the first relation which we are going to study is between E, G, W and S. E, as we know, is the voids ratio, G is the specific gravity, W is the water content and S is the degree of saturation. So whenever you go to derive relation between different terms, see that you have a diagram besides it. For example, the one which I have shown over here, this is a rough diagram which is representing the soil elements in terms of E. Soil elements which is represented in terms of E. E is nothing but the voids ratio. So this soil element is having voids and it is having the solids. Let us represent the voids as letter E and let us represent the solids as the letter 1. So what is the total volume V? V is nothing but 1 plus E, which is nothing but solids plus the voids. Okay, so whenever you are deriving the relation, see that you have a particular figure with U. Now let us go back to the derivation. Now let us represent EW as the volume of water, and we have E which is nothing but volume of the voids, and we have 1 which is nothing but volume of the solids. So this is pertaining to the figure which I have drawn. Okay, from the previous lectures we know the definition of S. S is nothing but degree of saturation, which is volume of the water by volume of the voids. Okay, now volume of the water can be written as EW, because for this derivation we say that EW is nothing but volume of the water, and volume of the voids can be written as E. Okay, so what is degree of saturation S? It is nothing but EW divided by E. Now let us cross multiply. We get EW is equal to S into E. So this is nothing but equation number 1. Okay, we already know that EW is the water voids ratio. Okay, that means all the voids are basically filled with water, and whenever it is a saturated sample, what do you mean by a saturated sample? It is nothing but the wet sample. That means all the voids are filled with water. So whenever it is a wet soil, EW is equal to E. That means the volume of the voids is equal to the volume of the water. Okay, because it is wet soil, all the voids are filled with water. Now we also know the definition of G. G is nothing but specific gravity, which is nothing but gamma S by gamma W, density of solids by density of water. On cross multiplying, we get gamma S is equal to G into gamma W. Let us mark it as equation number 2. Okay. Now what is water content? Water content is nothing but weight of the water divided by weight of the solids. Weight of the water can be written as EW into gamma W, and weight of the solids can be written as gamma S into 1. Okay, so what we have done over here is we are representing this weight in terms of voids ratio and in terms of density. And if you remember the previous figure which we had drawn, which was having voids and which was having solids, we marked voids as E and we named solids as 1. So the total volume which we took was 1 plus E. If you remember, this was the diagram shown in the previous slide. So this 1 is nothing but volume of the solids. Okay, now from equation number 2, we know that gamma S is equals to G into gamma W. So let us substitute. water content is equal to EW into gamma W divided by G into gamma W. Instead of writing gamma S, we have written it as G into gamma W. So what is common over here? Gamma W and gamma W gets cancelled. So water content is nothing but EW divided by G. Okay, what is water content? It is nothing but EW. EW is nothing but volume of the voids filled with water divided by the specific gravity G. Okay, so on cross multiplying, I get EW is equal to W into G. Now the equation 1 which we had derived, which said that EW is equal to S into E. Just refer to the previous slide. We had derived equation number 1. Now this is also for EW and this is also for EW. So let us equate both. S into E is equals to W into G. So if I take E out, I will get W into G divided by S. Very important equation from problem's point of view. So I have star marked it. Voids ratio is equals to W into G divided by S. Now coming to a saturated soil sample. Saturated is nothing but it is wet soil. So whenever the soil is wet, that means degree of saturation is 1 and W becomes W saturated. So the equation changes to E is equals to W saturated into G divided by 1. Okay, this is to be applied whenever it is saturated soil sample. Now let us go to the second one, which is relating the voids ratio, degree of saturation and Na. Na is nothing but percentage of air voids. So if you remember the three-phase diagram of soil, which says that soil is made out of air, water and the solid particles or the soil. So VA is nothing but volume of the air, VW is volume of the water and VS is nothing but volume of the soils. VV is nothing but volume of the voids. Okay, now voids are nothing but they are either filled with air or they are either filled with water. Okay, so what is the total volume? Volume of air, volume of water, volume of soils. What is voids? Voids is nothing but air plus the water. So can I write volume is equal to volume of the voids plus volume of the solids? Yes. Okay. So just keep the three-phase diagram ready besides. And this is the same old diagram which we had drawn in the previous slide. So let us represent the voids as E, solids as 1. So what is the total volume? Total volume is nothing but 1 plus E. Coming back to the derivation, we know that percentage of air voids is nothing but volume of the air divided by the total volume. Okay, now volume of the voids is nothing but volume of the air plus volume of the water. So what is volume of the air? Volume of the air is nothing but volume of the voids minus volume of the water. Okay, so volume of the voids is nothing but E. Volume of the water is denoted by the letter EW. This you will get from this particular figure. Similarly, what is the total volume? Total volume is nothing but volume of the solids plus volume of the voids. What is volume of the solids? It is 1. What is volume of the voids? It is nothing but E. So I can write it as 1 plus E. Now let us substitute. What is percentage of air voids? It is nothing but VA by V. We can write it as E minus EW, and this total volume can be written as 1 plus E. Okay, so I have just substituted over here. From equation number 1, we know that EW is equal to E into S. So let us write it in place of EW. Okay, so this is what I get if I substitute for EW. Here I shall take E common. So the equation is ready. Percentage of air voids NA is equals to voids ratio 1 minus degree of saturation divided by 1 plus degree of saturation. Coming to the third derivation, which we have between percentage of air voids, air content and the porosity. What is the definition of air content? Air content is equals to volume of the air divided by volume of the voids. What is the definition of porosity? Volume of the voids by the total volume. And what is the definition of percentage of air voids? Volume of the air divided by the total volume. Okay, so these are nothing but definitions. Now let me multiply air content into porosity. Volume of air by volume of voids into volume of voids by the total volume. So this is common, which gets cancelled, and what remains over here is volume of air by the total volume. So what is the equation? Air content into porosity is nothing but percentage of air voids. This is your third relation, which is again very important. Now going back to the next equation, wherein we are going to derive the relationship between gamma d, G and E. Gamma d, as we know, is nothing but the dry density, G is the specific gravity, and E is the voids ratio. Now what is density? Density is nothing but weight by volume. What is dry density? Dry density is nothing but weight of the dry solids divided by the total volume V. Okay, now what we shall do is, instead of keeping this as WD, that is weight of the dry solids, let us replace it by some other terms. Okay, density of solids is nothing but weight of the dry solids divided by volume of the solids. Do not get confused. This is density of the dry solids and this is density of only solids. Okay, so on cross multiplying, I can write WD as density of solids into volume of solids. Okay, so dry density can be written as density of solids into volume of solids divided by the total volume. Now this is the same diagram which I had shown on the first slide. Voids represented by E, solids represented by 1. So the total volume is 1 plus E. Okay. So instead of writing Vs, I can write it as 1. Okay. Because volume of soil is nothing but 1. And the total volume V can be written as 1 plus E. Okay, so what is dry density? It is nothing but gamma S into 1 divided by 1 plus E. Gamma S divided by 1 plus E. Okay, now we already know that this I had already derived. Specific gravity is nothing but gamma S by gamma W. So what is gamma S? It can be written as G into gamma W. So let me substitute. Gamma D is equals to G into gamma W divided by 1 plus E. This is another important equation which will give us the value of dry density gamma D. Suppose if I want to calculate voids ratio, after rearranging I get G into gamma W divided by gamma D minus 1. Okay. Now in all these slides, we referred the voids ratio. That is, the soil element was drawn in terms of voids ratio. Now here there is another diagram wherein we have the soil element which is represented in terms of N. N is nothing but porosity. So we have voids, we have soil. Let us represent voids by the alphabet N, and let us represent soil as 1 minus N. So what is the total volume? Total volume is voids plus the soil. So what remains is 1. So what is the total volume over here? It is nothing but 1. Okay. So what is volume of the soils? It is nothing but 1 minus N. What is the total volume? It is nothing but V. Gamma S is nothing but G into gamma W. So again, dry density is nothing but weight of the dry solids by the total volume. Dry density the density of solids can be written as weight of the dry solids by volume of the solids. So what is weight of the dry solids? On cross multiplying, we get it as gamma S into Vs, which I have written it over here. What is gamma S? Gamma S is nothing but G into gamma W. Okay, so G into gamma W into Vs divided by V. From the figure which I had already drawn, okay, we have the voids, we have the solids, this is N and this is 1 minus N. The total volume is 1. How it came I have already shown. So Vs can be written as 1 minus N, V can be written as 1. Okay, see, it is the same equation. If you remember, earlier we represented it with terms of T. Okay, if you remember here, see, it is the same thing which we had done, but this Vs and the volume was expressed in terms of E, in terms of voids ratio. Now what we are doing over here is we are representing it in terms of porosity. So I get gamma D is equals to G into gamma W 1 minus N divided by 1. Coming to the next equation, which is relating gamma saturated, specific gravity, voids ratio and the porosity. What is gamma saturated? Density of wet soil. That means weight of the saturated soil divided by the volume. Okay, so what do you mean by it is a saturated soil? Saturated soil means it is having the soil and it is having the water. Air is absent. So this saturated soil can be written as weight of the soils divided plus weight of the water divided by the total volume. Okay, we already know that WD can be written as gamma S into Vs. If you open the previous slide, you'll get to know how it is. In the similar manner, weight of the water WW can be written as gamma W into VW. It is on cross multiplying. So instead of writing it as WD, I'm writing it as gamma S Vs. Instead of writing as WW, I'm writing it as gamma W VW. And what is the total volume? The total volume from the figure is nothing but 1. Okay. So what is Vs from the figure? It is nothing but 1. What is VW? VW is nothing but E. And what is the total volume? It is nothing but 1 plus E. So what is gamma saturated? Gamma saturated is equals to gamma S into 1 plus gamma W into E divided by 1 plus E. Then we also have G, which can be written as GS divided by GW. Sorry, gamma S by gamma W. So this gamma S can be written as G into gamma W. This we have already used in the previous slide. So gamma saturated is nothing but G into gamma W plus gamma W into E divided by 1 plus E. I shall take out gamma W common. What I get is G plus E divided by 1 plus E into gamma W. This is the equation for gamma saturated in terms of voids ratio. Okay, see, the most important part over here is I explain this once again. Gamma saturated is nothing but weight of the saturated soil divided by the total volume. Saturated is nothing but weight of the dry soils plus weight of the water divided by the total volume. Gamma S can be written as WD divided by Vs. Okay, so what can I write WD as? It can be written as gamma S into Vs. So this is one important part which we always have to remember. Also, WW can be written as, it can be written, okay, yes, sorry. Now I want to represent WW, which is nothing but gamma W is nothing but WW divided by VW. So WW can be written as gamma W into VW. This is second one. So here is where the students get confused that how this has come. So I have explained it once again over here. Okay. Now, coming to the next one, wherein we are going to represent it in terms of porosity. I have already told you, let us represent voids as n, and let us represent soil as 1 minus n. So, what is the total volume? It is nothing but 1. So, gamma saturated is gamma S into Vs, gamma W, Vw divided by the total volume V. So Vs is nothing but 1 minus n, Vw is nothing but n. This is from the figure. Total volume is 1. So gamma saturated can be written as G into gamma W 1 minus n plus gamma W into n. So I have represented gamma saturated in terms of porosity over here. So a total of 5 derivations. Okay,